This covers chapter 10 from the GCSE textbook, and it covers linear graphs. Linear graphs. Now the word linear just means straight line. So this is straight line graphs. Okay, so all these graphs are going to be a straight line. They're not going to be zigzags. They're not going to be any other shape. They're going to be straight line. And how do we know it's linear? Look at the first four letters of the word linear, line. So these are all graphs that give us lines. So we're going to go through the list. The first thing we've got is reading off from a conversion graph. Okay, so that is this bit here. There's not much I need to say about conversion graph. Let me draw one. So let's say I had a graph that looked something like this. Okay, and this converted, I don't know, stones to kilos. Yeah, and actually if it was converting stones to kilos, the line wouldn't look like that. It would go through the origin, so it'd probably be something like this. The key thing is if you're reading off from a graph, if I was changing stones to kilograms, then I would read off this way. Okay, so I'd go up and across. Or if I was converting kilograms to stones, I would go this way and read off down here, which probably means I need to make my axis a little bit longer down here. Let's make that a longer line. So I could actually read off, so it'd probably be something like that. The important thing is that when you read off from a conversion graph, draw those lines in to show that you are doing the conversion, to show where you're reading off. Okay, so I'm going to say always draw in the lines to show how you are reading off the graph to convert it. Okay, so that's really important. Don't just read off and put the answer down, because the examiner's looking to see whether you put those lines in, and that will make sure that you maximize your marks. Right, the second thing on the list here is can draw a linear graph without being given a table of values. So that what that means is that you need to create your own table of values. So sometimes you need to do that, create your own table of values. So let's have a look at how we do that. So let's say we had a question that said plot and draw y equals 3x minus 5. Then what you would do is you would create your own table of values. So I'm going to pick 3 values of x and work out what the values of y are. Now I always suggest that the 3 values of x that you pick are 0, 1 and 2. You want to make it as easy as possible. So pick 3 values, don't pick 2. Pick 3 values and do 0, 1 and 2. And then what we're going to do is we're going to replace x with 0. Then we're going to replace it with 1. Then we're going to replace it with 2 and work out what we get for y. So the first value of y is going to be 3 times 0 minus 5, which is negative 5 minus 5. The next value of y is going to be 3 times 1 minus 5. So that's 3 minus 5 is negative 2. And then the next value of of x is 2. So that's 3 times 2, 6 minus 5 is 1. Then once I've got my 3 values, I'm going to plot them on a coordinate grid. So I'm going to attempt to draw one here. I'll need to be a bit longer, and I'll need to move my axis. I'm going to try and plot all of these on here. So let's say it was something more like this, with my y-axis here and my x-axis here. Now what I've got is each column represents a different set of coordinates. So each column I have represents a different set of coordinates. So the three coordinates I'm going to plot are 0, -5 from the first column, 1, -2 from the second column, and 2, 1 from the third column. Okay, now why have I done that? Because in this rule that I've written, y equals 3x minus 5, so y equals 3x minus 5, this x here stands for the x coordinate, and the y here stands for the y coordinate. So basically what my rule is saying is take the x coordinate, times it by 3, then take away 5, and that gives you the y coordinate. So let's plot these. Now this isn't perfectly to scale because I'm having to draw up my own grid. So it's got -1, -2, -3, -4, -5 here, and then 1, 2, 3, 4 here, 2, 3, 4. And then I'm going to have my y-axis. Now I need to get down to -5. So what I'm going to do is this. Let's do -10, -5, 5, 10. So I've got like a slightly different scale on the y-axis. Let's see how we go. Obviously your grid will be much bigger than this. So the first point is -5, y is -5, x is 0. So remember, you go along the corridor, up the stairs or down the stairs. So 0, -5 is here. 0, -5 is not here. This is -5, 0. So remember, the first number is across, the second number is up or down. The second coordinate is 1, -2, so that's 1 across, -2 down. So that's going to be something like this. And the third coordinate is going to be 2 across and 1 up, so it's going to be something like this. Then once I've drawn them, I join them up with a straight line. So let's do this in purple, like this. Yeah. And then you always extend the line to the full size of the grid. Yeah, so always extend the line to the full grid. So don't just join up the 3 points that you've done. And the second point is, because it's a linear graph, this should be a straight line. If you've got any zigzags, anything like that, anything out of place, then you need to go back and check that you have plotted it correctly. Right, this leads on actually to the next couple of topics here to do with the straight line, and that is to do with the gradient and different ways of drawing a straight line. So let's start by looking at how we can find the gradient of a straight line. So all straight lines, not all straight lines, but you can write the equation of a straight line in this form. Okay, so this is one form of the equation of a straight line. There are different ways of writing it. Now this is really useful because it tells us what the gradient is. The number that's in front of x is the gradient number. Okay, the number in front of x is the gradient. The number that's on its own here gives you what we call the y-intercept. It is where the graph crosses the y-axis. So the number in front of x gives you the gradient. The number on its own gives you the y-intercept. So here's a few for us to try. If I had y equals 7x minus 2, this line has a gradient of 7 and it has a y-intercept of -2. It crosses the y-axis at -2. If I had this one, y equals 10 plus a half x, Don't let the order fool you. Here the gradient is a half. It's the number in front of x. And the y-intercept would be 10. If I had something like this, y equals 0.7x with nothing else. Okay, what this means is that this has a gradient of 0.7 and a y-intercept of 0. Now, because we can easily find what the gradient and the intercept is, we can draw straight lines using what we call the gradient-intercept method, which is what we're going to do now. So if we're going to use the gradient-intercept method to draw a line, okay, let's just write this down here, gradient-intercept method. In fact, there are 3 different ways we can draw a line. One is the gradient-intercept method. Other methods are filling in a table, so using tables, which we done in the last example. We made our own table. Sometimes you get a table in a question, you just need to complete it, fill in the missing numbers. We're looking at the gradient-intercept method, and after this we're going to be looking at the cover-up method. Yeah, so there are 3 different methods. Now, the gradient-intercept method, what do we do? Well, once we've got our line, the best way to show you is with an example. Y equals 2x plus 5. Right, this is what I do. I've got my coordinate grid like this, with x here and y here. Let's put some numbers on. Whoops, y not x. So let's put some numbers on. 1, 2, 3, 4, 5, 6. And numbers here. 1, 2, 3, 4, 5, and 6. Hopefully they're fairly spaced out, right? And the first thing that I do, I'm going to look at this number here, the 5. That is where the line crosses the y-axis. So I'm going to put a cross where 5 is there. And that is actually the coordinate 0, 5. Yeah? Because it's 5 on the y-axis. Right. To get the other point, I'm going to use the gradient. Now, what does the gradient mean? The gradient actually means, the way that we find the gradient is we do the rise divided by the run. Now, what do I mean by that? What I mean is, if I have my straight line like this on a coordinate grid, there's another coordinate grid here, like this, and I want to work out the gradient, I pick 2 points that are whole numbers that are easy to read off. Between those 2 numbers, I look at how much it goes up, which is the rise, and how much it goes across, which is the run. And if I do how much it goes up divided by how much it goes across, that will give me the gradient. Now, lines which go up have a positive gradient, lines which go down have a negative gradient. So if the line was going down like that, the gradient would be a negative number because the rise would be going down by a certain number of squares. Just like correlation and scatter diagrams, if the line goes up or the crosses go up, it's a positive correlation, positive gradient. If the crosses go down, then you have a negative correlation and you would have a negative gradient if it was a line. So the rise divided by the run in this question is 2. So something divided by something is 2. So I could pick any pairs of numbers where if I do one divided by the other, they equal 2. So for example, let's see here, if the gradient is equal to 2, okay, I could have a rise of 2 and a run of 1. So 2 across, sorry, 2 up, 1 across. I could have a rise of 4 and a run of 2. You go up 4, you go across 2. I could have 6 and 3. So 6 up, 3 across. I could use any of those to get the other point. Now what I'm going to do is from the point that I've already drawn, which is here, I'm going to use this. That gives me a gradient of 2. All of these give me a gradient of 2, but I'm going to pick the smallest one. So what does this mean? That means from this cross here, I'm going to go up 2 and across 1. Yeah, a rise of 2 and a run of 1. That does mean I need to add another number here. So let's put 7 here. So I'm just going to draw this in, but you'll probably take it out afterwards. You wouldn't really draw this. So I'm going to go up 2 from here, 1, 2, and then across 1. So across 1 to here, and then put that cross in. Okay, and then I join them up. I get my straight line like this, and I'd make that line go all the way through the grid. So this line has a gradient. Whoops, didn't want to do that. Just the blue line I wanted gone. Let's put that back in. This line that I've got here has a gradient of 2 because it has a rise of 2 and a run of 1, or 4 and 2 would have done, or 6 of 3, or any two numbers that divide to make 2. And it goes through the y-axis at 5. So that's the gradient-intercept method. So you plot the intercept and you use the gradient to work out what's the second point that you need to plot. The gradient will tell you, or you need to find two numbers, one divided by the other, the rise divided by the run, that will give you that gradient, and you can use it to plot the second point, and then you just join them up. Remember, make the line go all the way through the grid. So the third method we haven't talked about yet to draw a line is the cover-up method. So we've used the table method in the first example. We've just done the gradient-intercept method. Let's look at the cover-up method. So this is a different way of drawing a line. Now this works really well for straight lines that are written this way. ax plus by equals c. Now what does that mean? A, b and c can be any number. So they will look something like this. 5x plus 2y equals 10. Or negative 3x plus 7y equals 21. Or it might even be the other way around, where you have something like negative 4x, not 4x, I was going to say negative 4y plus 3x equals 24, or maybe even negative 24. So can you see the pattern that these ones make? This is the, we'd use the cover-up method. So the way that this cover-up method works is we're going to generate two coordinates by covering up part of the equation. So here's my x and y axis here. And I'll do 1, 2, 3, 4, 5, 6. And the same on this axis. And what I'm going to do, I'm going to use the cover-up method to draw this line. And this line is going to be a line with this equation. 3x plus 2y equals 6. Right, so the way that this works, I'm going to cover up, first of all, the x part. So basically, I'll cover up that part. So imagine that black blob is your hand. Now, the bit that I covered up now becomes 0. Okay, so I covered up the x part, so I'm going to put 0. What I'm left with is 2y equals 6. So 2y equals 6. Y, remember y stands for the y coordinate, must be 3. So by working out what that is, I get 3. That gives me one coordinate. Okay, what I'm going to do now is I'm going to cover up the other part. So I'm now going to cover up the y part. So this gets covered up like this. And when that gets covered up, the y part gets covered up. So that means that the y coordinate is now 0. What you cover up becomes 0. and I'm left with 3x equals 6. So 3x equals 6, that means that x equals 2. So I'm just going to write 2 down. So using that cover up method, by covering up either the x part or the y part, what I've got now are 2 coordinates. I plot those 2 coordinates, so 0, 3, 0 across 3 up. I plot the other coordinate, which is 2 across 0 up, and there I have my points, which I can use to draw my straight line. So I now draw a straight line through them like this. Okay, let's say I had a different one. So let's say that my straight line was 5y minus 2x equals 20. So I'm not actually going to plot this line, I'm just going to work out the coordinates. So we cover up this part. So that leaves me with negative 2x equals 10. Now what have I covered up? I've covered up the y part. So if I've covered up the y part, I'll make the y coordinate 0. And the x coordinate, well, x has to be negative 10 for that to work. Negative 2 times negative 10 is 0. I now cover up the other part. So I put that back, which means I need to put the y back. That's disappeared. So now let's cover up this bit, the negative 2x here. And so since I've covered up the x part, that means that x is now 0, x coordinate is 0. I'm left with 5y equals 20, which means that y equals 4. So these would be the 2 coordinates that I would use to plot that line. Okay, so that's the cover-up method. So use it when you see equations of lines given that look like this. If it's given in the form y equals mx plus c, like the last ones we've done, then what you should do is use a table or use the gradient-intercept method. Right, the next bit is about finding the equation of a line. Okay, so that is this bit here, finding the equations of a line. That's also using graphs to find formula, so these two go together. So how can we find the equation of a line? Well, it's almost like the gradient-intercept method backwards. We look at the intercept, we find the gradient, that will give us the equation of a line. Right, okay, so if you've got a line like this, and this line, let's say it went down like this, so I know it's got a negative gradient. Let's say that this was the number 5, and let's say that I picked 2 points on the line, that one and this one, the coordinate of this point was 3, 6. Right, so like the gradient intercept method but backwards. So I know that this line is going to go y equals mx plus c. C is very easy, that's where it crosses the y-axis, and that's 5. So I know that it's y equals mx plus 5. That's where it crosses the y-axis. The next thing I'm going to do is to work out the gradient. Now I've already picked a point on the line, 2 points on the line. And what I do, I look at the rise and the run between those 2 coordinates. Now this one goes down, so the rise is negative. The rise is going to be, goes down by 2, negative 2. And the run, it goes from 0 to 6, it's got a run of 6. So the gradient of this line, the rise over the run, how much it goes up or down by how much it goes across, is negative 2 over 6, which I can simplify to negative 1/3. That is the gradient. So I can finish off the answer by writing y equals negative 1/3 x plus 5. So that would be the equation of the line. I looked at the intercept and I worked out what the gradient was by picking 2 points on the line. Now let's say instead this wasn't x and y, let's say this was t for time and C for cost. Well, the only difference would be instead of y equals mx plus c, I would replace the y with the letter c, because that's what I've got on the y-axis, and I'll replace the letter x with t. Yeah, so all I did was whatever's on the y-axis, I put that letter instead. Whatever's on the x-axis, I put that letter instead. So the equation of this line would be c equals negative a third t plus 5. So you can see it's pretty much the same as this one down here. We're just using different letters. So that's that bit where it says I can use graphs to find formula. Don't let the graphs confuse you. They're just different letters. Match it up with y equals mx plus c. Just use the different letters that are there. Right, we're now on to the last section here, which is using graphs to solve simultaneous equations and drawing graphs of parallel or perpendicular lines. Right, let's start with using graphs to solve simultaneous equations. Right, what does that mean? That basically means writing down the coordinate where two lines cross. Let's say I had a line like this. Let's say that the equation of this line was y equals 2x plus 4. And let's say I had another line that was like this. And so let's put some numbers on here. So this would be the number 4. And let's say that this was the number 6. And this was the number 10. So actually, the equation of this line would be this 6x plus 10y equals 60. I basically just used the cover-up method and worked backwards to work out what it would be. You can check that for yourself. And if the question said that you needed to solve these simultaneously, we can do this by algebra. That comes later in the book in another chapter. If it says solve it graphically or by using the graphs, all you do is you work out the coordinate where the two lines cross. So you find this point here, you work out what that coordinate is, you would just read it off like this, find out what those numbers are. I don't know what they are. I don't want to guess in case they're wrong. So you actually find the coordinate where the two lines cross. And once you found out where the two lines cross, you write that coordinate as x equals and y equals. Yeah, so take those numbers from the coordinate and write them down. So you'll have two numbers, one here, one here. So you write it as x equals and y equals, because remember, the x coordinate, or x means the x coordinate, y means the y coordinate. So don't just write down the coordinate, write down, okay, x equals, or basically the x coordinate equals, and y equals, basically the y coordinate equals. So that's how we would solve simultaneously. Sometimes the lines are drawn for you. Sometimes you need to draw the lines yourself, and you can use any of the methods that we've talked about to draw the lines. But you need to write down the coordinate where they cross, the two lines cross, and write it as x equals and y equals. So the last thing we're going to be looking at is perpendicular and parallel lines. Right, now parallel lines have the same gradient. So if I had a line like this and another line that was parallel to it, if this was the number 2 and this was the number 7, and this line had the equation y equals 3x plus 2, well, this one would be y equals 3x plus 7. Yeah, parallel lines have the same gradient. So these two lines would be parallel. We'll either be told it or there'll be like arrows drawn on it. So parallel lines have the same gradient. And the last thing is perpendicular lines. So let's say I had another line on this grid that was perpendicular like this. Actually, I'm going to do it slightly lower. Let's say I had a line like this. I actually want it to cross the y-axis like that. Okay, so let's say that these two lines are perpendicular, which means that they're at right angles. And this line crosses the axis at, let's say, 10. I know this isn't to scale, but don't worry about that. So can we work out the equation of this line? Yes, we can. There is a link between the gradient of a line and the gradient of a perpendicular line. If you have a perpendicular line, its gradient is -1/m, where m is the gradient of the original line. Okay, so if the gradient of this line is, the original line is m, actually, which is 3, the gradient of this line is going to be -1/3. So it actually has a gradient of 1/3, that red line. So we could write down the equation of this line as y equals -1/3 x plus 10, because that's where it crosses the y-axis at 10. So we took the gradient of the line that we know, the purple one. If we know that a line is perpendicular, we use that -1/m, where m is the gradient of the perpendicular line, the one that we know.